When a typhoon drenches the Tokyo region, the most dangerous moment usually arrives hours after the rain began. That is when small rivers and low-lying, heavily developed neighborhoods start to crest. The flat landscape cannot release this volume quickly enough. Instead of attempting to contain the water at the surface, engineers deliberately allow parts of those rivers to escape straight down. The flood drops into shafts roughly as deep as a 23-story building. This is a dynamic, hidden river. It is built to intercept dangerous overflow and move it beneath developed land, providing a safer route out before the surrounding streets and homes can flood. Known officially as the Metropolitan Outer Area Underground Discharge Channel, the system sits in Kasukabe, Saitama, on the northern side of the Tokyo metropolitan region. The basin forms a shallow bowl. With gentle river slopes, water drains slowly. Urban development makes this worse. Rain on roofs and roads reaches drains faster than open ground. The volume is the same, but delivery is compressed into a shorter, dangerous period. The machine creates another choice. Along several rivers, overflow structures sit at carefully chosen heights. As the river rises, it eventually passes naturally over an intake levee and through mechanical screens that catch debris like branches and plastic before the water enters the system. During an extreme storm, the basin begins filling like a bathtub with a drain that is far too slow. Without this mechanical intervention, the water has only bad choices, overtopping banks and cutting off transport links. After filtration, the water reaches 5 giant shafts. Each one is 70 meters deep and roughly 30 meters across, wide enough to contain the Statue of Liberty. Moving water to a tunnel buried 60 meters below creates a major engineering challenge. Sawing water carries massive energy. If it simply plunged to the bottom, the impact would destroy the intake structure. To manage this force, the water is guided down along the curved walls of the shafts. This controlled, spiraling descent reduces the impact at the bottom, turning a destructive vertical fall into a manageable flow. At the base, the flood enters an artificial underground river. This 10-meter wide tunnel runs for 6.3 kilometers, situated roughly 50 meters below ground, deeper than many of the city's subway lines. Engineers placed this artificial river directly beneath the existing Route 16 transportation corridor. This allows the system to collect and move floodwater beneath developed communities without requiring a giant open canal at the surface. At the end of the tunnel, the water enters a pressure-adjusting tank 177 meters long. It contains 59 concrete pillars, each 18 meters tall and weighing 500 tons. During an operation, this chamber regulates momentum. Water arriving through the 10-meter tunnel possesses too much energy to be sent directly into the pumps without making them unstable. The chamber also provides a buffer against backflow. If emergency brakes stop the pumps, the space allows the surge of water to expand and stabilize before it can push back toward the tunnel. This diagram shows the physical forces on the structure. Because the chamber sits in a high water table, groundwater presses upward, creating buoyancy. The massive pillars, floor, and ceiling beams provide the weight required to pin down the chamber and prevent it floating. A public soccer field sits exactly 22 meters above this concrete flood control space. The system's power is concentrated in the Showa drainage pump station. 4 gas turbines, adapted from 14,000 horsepower aircraft technology, rotate massive impellers to lift 200 cubic meters of water every second. At this rate, the volume of a standard Olympic swimming pool passes through the system in 12.5 seconds. The water is forced into the Edogawa River, carrying the flow safely away toward Tokyo Bay. The value of this chain becomes clear during a real storm. In August 2024, during Typhoon Shanshan, the complex began receiving water shortly after 5 in the morning and continued to pump it away as the rain intensified. By the end of that event, the system had captured enough water to fill the Tokyo Dome Stadium almost 4 times over. However, the machine has limitations. During heavy rainfall in June 2023, more than 4,000 homes in the wider basin were still inundated. No tunnel has infinite capacity. The shafts only receive water from specific rivers, and the Edogawa River must itself remain a safe destination for the diverted flow. The underground channel is just one layer in a larger flood control network. It reduces risk in the specific area it serves, but it cannot abolish the physical limits of the landscape. The system functions as a sequence. Overflow structures intercept rising rivers, screens remove debris, curved shafts control the descent, a deep tunnel moves the water beneath the city, and the pressure chamber stabilizes flow for the final turbine lift. At the surface, the experience remains ordinary. Rain strikes windows and traffic moves carefully through the storm, isolated from the redirection of an entire river occurring 50 meters below. This machine exists so that when the landscape begins to lose control of its water, the people living above don't have to see what the alternative would look like.